Good morning, my students. Thank you so much for watching this YouTube video lesson. Again, I apologize I can't be there in person. However, virtual Mr. Ripes is here with you so that learning can continue. All right, so I'm told you got shortened classes today, so let's get right to it. First of all, today's video is brought to you by Inequalities. Yes, that's right. Thank you, Inequalities, for reminding us every day that life is not always equal. All right, let's get to the program. All right, first and foremost, everyone, if you haven't had the chance already, on Canvas, you'll notice right to the left of this video is the link that I want you to click so you can check your solutions to the multi-step inequalities review. Please have ready pen or a different color in which you did the original work from, Post-it notes so you can begin your corrections, of course. No pencils allowed. Keep that in mind. And I want you to scroll through that file at your own pace. And as you scroll through it, you'll notice that all the solutions and all the number lines and interval notation, it's all there. So I want you to scroll through it at your own pace. Click the link right to the left of this video. It's right there. And go through that first. Once you're done with that, then please unpause this video and continue on with the lesson. All right, pause it now. Check your work. All right, welcome back. Hopefully you did all right in that multi-step inequalities review. Again, reach out if you have questions. Math Lab is open all day today, according to that Canvas post. Please make sure of that. You can come at any time. I will be here with my laptop, ready to take whatever questions you have for your corrections. And there's also Math Lab, of course, tomorrow morning. Now, that being said, we ended class with these two and compound inequalities, and I did ask you to complete them so you can jump right in, check to make sure that you got these right, and before we proceed to the or compound inequalities today. So the one with -5 is less than or equal to negative x minus 3, which is less than or equal to 2. In the end, you would have gotten the interval of -5 to 2. And the one with the 24 and the 2 that you had to distribute right here, did all your math correct, and you're welcome to leave them as improper fractions. In fact, I encourage it. You would have gotten -9/2 and 19/2. So all the solutions are between -9/2 and 19/2, but not including -9/2 itself. So open circle and parentheses. All right, hopefully you did all right on those. And again, I hope this all goes under the vein that if you can solve an inequality, you can solve a compound inequality. And hopefully you're starting to agree with that. All right, before we get to the or compound inequalities, please, I want you to try to warm up your mind with one more and compound inequality. And here it is. -1 is less than or equal to -5x plus 2, which is less than or equal to 4. All right, I'm going to give you a time to work on this. So pause the video now. And when you're done, unpause the video so you can see the solution. All right, pause the video now. Good luck. Welcome back. How'd you do? Did you get the interval between -2/5 and 3/5? Yes, once again, leave them as an improper fraction. Okay? No need to change it to a decimal if you don't want to. And please do not change it to mixed numbers. Remember, algebra does not like mixed numbers. And both those should be in brackets and closed dots, and the number line you're shading between the two numbers. If you got those correct, excellent work. You are fully ready for the next level of compound inequalities called or compound inequalities. And once again, I must reiterate the fact that if you can solve an inequality, you can solve a compound inequality. So let's get to it. All right, let's talk about or compound inequalities. And I want to start by talking about, well, we got one more mashup to discuss here. Let's mash up the inequalities of x is greater than or equal to 2 and x is less than -5. But we're not going to mash them up with the word and, we're clearly going to mash them up with the word or. Now watch this, everyone. First, I think we'd all agree that x is greater than or equal to 2. All right, my 0 is here, my 2 is here. Closed dot at 2, and boom. To the right, all numbers right of 2 would be greater than that. And then if we're talking about x is less than -5, here's my 0. I'll put -5 to the left of 0. Remember, it does not have to be to scale, so you can put it anywhere to the left of 0. Open dot this time, and I'm going to shade all the number line that is to the left of -5. Well, let's mash it up one more time. I'm going to bring this number line that I already shaded, and I'm going to drop it right down here, right on top of the original one. And as you can see, there is no overlap this time, like there was with and. Yeah, that's going to happen because now we're talking about or. We are literally talking about any number that happens to be less than -5 or greater than or equal to 2. So that's exactly it. I mean, let's think about this, everyone. Any number that's less than 5 is going to be in that yellow shade. Any number that's greater than or equal to 2 is going to be in that blue shade. So any number that is less than -5 or any number that's greater than +2 is going to be a solution to this inequality. Let's test that theory. I think we'd all agree that greater than or equal to 2 is, I don't know, let's say 8. All right, so if I erase both of these x's and replace them with 8's, let's look at here. 8 is less than -5. Well, no, that's not true. But 8 is greater than or equal to 2. That one is true. But what about the entire statement with the or and all? Is the entire statement true with only one of these inequalities being true? Yes, because with and, both of the inequalities, both of the conditions have to be true. But with or, because it's or, you have choice, only one of the inequalities has to be true. So, is 8 less than -5 or 8 is greater than or equal to 2? Yes, that entire statement is true because it's or. Only one of those conditions, one of the inequalities has to be true. Again, because it's or. Well, what about on the other side of that? What if we didn't choose 8 here? What if we chose a number like, oh, I don't know, -10? Well, let's see here. Let's replace these with -10. And we've got -10 is less than -5. Hey, that is true. Or -10 is greater than or equal to 2. See, this one's not true, but the left one is true. But the whole statement is still true because it's or. Only one of the conditions, one of the inequalities has to be true in order for the whole thing to be true. So, to graph a compound inequality with or, you literally have two branches going one way and the other. So how would we write this in interval notation here? Well, we've got two separate pieces here. This one right here, we know goes from -infinity with parentheses all the way to -5 again with parentheses. And we know this section right here goes from 2 with a bracket all the way to +infinity with a parentheses. Well, again, this is a mashup. You're not going to kind of keep them separate. We need some symbol right in the middle between our two interval notations. And you might recall the symbol for or. We talked about it yesterday. Is it this upside down U or is it this kind of right side up U? If you're looking at your notes, that's good. It's the correct U. It's called the union, okay? And this means or. So basically what you have to do is you literally have to put the word, well, no, not the word, you have to put the symbol for or in between the two branches of your compound inequality with an or. And each one of these represents one sort of section, one branch that you highlighted on the number line. So the entire thing in interval notation consists of two interval notations joined together with the symbol for or. So we're literally saying all numbers between -infinity and -5, but not including -5, or all numbers between 2 and infinity, but including 2 itself. All right. Now let's practice more on this. Now that we know how to graph them and put them in interval notation, all right, let's do it, everyone. Let's practice a little bit more. We got two more right here, okay? So let's see here. 8 is less than 0. All right, so I'm going to put my, x is less than 8, pardon me. I'll put my 0 there. I'm going to put my 8, I'll put it right here, and I'm going to open dot there. And numbers that are less than 8 are going this way. And x is greater than 11. All right, I'll put my 11 right here. That's another open dot. And numbers greater than 11 are going this way. So there it is, kind of two branches. One going to the left, one going to the right. Now how do we put this in interval notation here? Well, this blue branch over here goes from -infinity all the way to 8, not including 8, so parentheses. And then the yellow branch goes from 11 to +infinity, both parentheses. And again, we're going to join them because this word or has to be part of our answer. We're going to put that or right in the middle. And remember, it's that giant U. Represents or. And there it is in interval notation. All right, can you Pause the video now, and can you graph x is less than or equal to -9, or x is greater than or equal to -1, and then also write it in interval notation. Don't forget the U symbol that represents OR. Pause the video now, give it a shot. When you're done, unpause it. Let's see how you did. All right, welcome back. How did you do? Did your number line look something like that? And did your interval notation look something like that? Remember, you need brackets next to the -9 and the -1. But don't even think about it with infinity. Positive or negative, doesn't matter. Always parentheses. All right, so now that we know how to graph it, and now that we know how to put it into interval notation, how do we solve them? Well, here's the nice thing. I'm going to say this one more time. If you can solve an inequality, you can solve a compound inequality. If you can solve an AND compound inequality, I promise you, you can solve an OR compound inequality. Because OR compound inequalities, they always will have the word OR between them. So thank goodness for that. You can always recognize an OR compound inequality because the word OR is literally going to be stuck in between two of them. So how to solve them? Well, I got to say this, everyone, students. It's the same techniques as before. All the symbols remain the same. The open and the closed dot, that all remains the same. And I must stress it one more time. You still got to flip the sign if you multiply or divide both sides by a negative number. Okay? So here's our first one. 2x plus 3 is less than 9, or 3x minus 6 is greater than 12. Whenever you have an OR compound inequality, again, the word OR is always stuck between the two inequalities, and there it is. I always like to think of these as 2 for the price of 1. All right? It's kind of like math is cheating us. It's kind of like giving us 2 problems, but they're calling it only 1 problem. Because the way you solve these is quite simple. Take one of them and ignore the other, and even ignore the OR sign, okay? Let's say I just wanted to focus on 2x plus 3 is less than 9. I believe that all of us would agree that we're going to start by, I don't know. That's right, subtracting 3 to both sides. And so we get 2x is less than 9 minus 3. Oh, yeah, that's totally 6. And then to get x alone, we're going to divide both sides by 2. We're not going to flip the sign because we are dividing by a positive 2. So x is less than 3. Great. You're done with that first one. All right, well, what do you do next? You might see where I'm going with this. Now we're just going to tackle that second one that we ignored, 3x minus 6 is greater than 12, completely independent of everything that we just did. So just ignore it for now. You don't scratch it out, of course, but just focus on 3x minus 6 is greater than 12. Completely ignore what we just did. And yep, start by adding 6 to both sides. Very good. And so we get 3x is greater than, 18. And then, of course, we're going to divide both sides by 3. We're dividing by a positive 3, so no need to flip the sign again. So x is now this time greater than 6. And so now if we look at both of them, we've solved both of them independently of each other. Yeah, that's how it works. Just remember one very important thing in your final answer. Bring down that word OR, because our final answer is any number that is less than 3 or any number x that's greater than 6 would be the solution to this OR compound inequality. Let's go ahead and graph that, put it in interval notation, and then of course it's important to kind of check our work to see if we got this correct. So let's see here. I got a 0 here. I'm going to put my 3 here, put my 6 here. Open dots at both, and let's see here. Any number that is less than 3 is going this way, and any number that is greater than 6 would be going this way. Beautiful. Once again, we're seeing it's kind of taking the number line and breaking it up into 2 branches away from each other. So in interval notation, negative infinity, comma 3 with a parentheses, or, there's that U, 6, comma, infinity, all parentheses. Beautiful. Let's make sure that this is actually true, though. Okay, now remember, in an OR compound inequality, only one of these conditions has to be true. So let's choose any number. That is, let's start with less than 3. Let's try 0. 0 is less than 3. That's a good one here. So I'm going to replace both of these x's in the original compound inequality, both of them with 0. And let's see what we got here. Well, 2 times 0 is 0, so we got 3 is less than 9. That checks out. And then we've got negative 6, because 3 times 0 is 0. Negative 6 is greater than 12. See, that doesn't check out. But again, it's like we were saying earlier, because of that word or, only one of the conditions, one of the inequalities has to be true in order for the entire compound inequality to be true. And we see that the left inequality is in fact true, regardless that the right one is not. So we're good. 0 is a solution because it works in only one of the inequalities. Well, what about numbers that are greater than 6? I don't know. Choose any number greater than 6. Let's choose, let's choose 10 again because that's another good one to use. So I'm just going to put a 1 there. Actually, let me zoom in here so you can really see it. I'm going to put a 1 there, make that 10. And once again, I'm going to put a 1 there, make that 10. So let's see here. Let's get rid of all that. And let's see if 10 does work. Well, 2 times 10, that's 20 plus 3 is less than 9. Yeah, no, 23 is not less than 9, but hopefully the other one will give us a shot here. 30 minus 6 is greater than 12. Well, yeah, I mean, we know that's true, so boom, 10 did in fact work again. So now this time, the other inequality works, but the first one didn't. So it's just the opposite of what we saw, which means 10 is a solution because it works in only one of them. Now, one more thing, any number between 3 and 6 shouldn't work. All right. Let's test that theory. Let's test 5, which we know is between 3 and 6. And let's see here. You might see where I'm going with this. It shouldn't work in either of them. And let's just see if it doesn't work in either of them. Let's put a 5 here. Let's put a 5 here. We've got 10 plus 3 is less than 9. Well, no, it's not because 10 is already greater than 9. So we know if you add 3, it's still not going to be greater than 9. Or it's not going to be less than 9. And we've got 15 minus 6 is greater than 12. Well, we already know that's not true. So it didn't work in either of them. So we know that 5 is not a solution because to work in an or compound inequality, it has to be at least one of the inequalities true. Cheers, everyone. That's an or compound inequality. It's like 2 for the price of 1. Math is kind of cheating us, saying, oh no, it's really one problem. But in reality, it's kind of 2. Oy. All right, let's try another example here. I got a few of them here. I got 3 of them I want us to do. So our next one here is 3x plus 1 less than -5, or 2x minus 5 is greater than 7. All right, let's see what we got here. I'm going to start. It doesn't matter which one you start with. That's the nice thing. You know what? Just to shake things up, I'm going to start with the one on the right here. Yeah, I'm going to add 5 to both sides. And again, I'm solving the 2x minus 5 is greater than 7 completely and utterly independent of the other one. We know that's 12. I'm going to divide both sides by 2 again. Oh, that seems to be a common theme. X is greater than 6. Oh, there's that 6 again. All right, well, now I can do the other one. I'm going to subtract 1, subtract 1, and I'm left with 3x is less than -6. I'm going to divide both sides by 3. And this time, do I flip the sign? Good, I don't. It doesn't matter that this 6 is negative. What matters is that what I'm dividing both sides by, in this case 3, is in fact positive. So x is now less than still -2. Wow, not bad. Just one more thing. Do not forget to bring down the word or, so that your final inequality contains the word or in between your 2 inequality solutions. Here's 0, here's -2, open dot, so I'm going to shade left of -2, and then I got a 6 somewhere here to the 0, and I'm talking about that right there. Beautiful. In interval notation, lots of negative and positive infinities with or compound inequalities. That's typically going to be the case because of the 2 kind of branches that you're graphing here. Parentheses, or, which is the u, parentheses 6, comma, infinity, parentheses. Boom. Done. Not bad. All right, the next example, in fact, the next 2 examples, I would like you to try on your own. Here they are. All right, again, these are 2 separate ones. Notice that they have the word or in between them. So again, I'm giving you 2 problems, but I'm kind of giving you 4. Pause the video now, work on both of these, and when you're done, unpause the video, and let's see how you did. All right, everyone, pause the video now. Good luck. Hey, welcome back. Let's see how you did. Did your number lines look like this? Did your interval notations look like this? And did your final solutions look like this? Yeah, for only one of them, depending on how you did you have to flip the sign? I was dividing both sides by -1 so that greater than became less than. Now again, depending on how you worked this one here, you may have had to flip the sign, depending on which variable term you worked with. If you subtracted the 6x to both sides instead of the 5x to both sides like I did, no problem. You still would have gotten the same answer as long as your math is correct, but you would have had to flip the sign for that one. But there you go, everyone. It's nice to know that if you can solve an AND compound inequality, you can solve an OR compound inequality. Are there any other types of inequalities? Yes. Are there any types of compound inequalities? No. There's AND and there's OR, but we still have to talk about absolute value inequalities. But we will get to that next week. Very exciting. Very proud of you all. Now, one more thing, if you don't mind, look back through your notebook, flip through your notebook, and look at all just the number lines. Look at all the AND compound inequality number lines. Do they all kind of look alike? Look at all the OR compound inequality number lines that we graphed. Notice a pattern there? Did they all kind of follow a same format? The ANDs and the ORs, did they all kind of follow a same format? Maybe you noticed that. And I know you all have very keen eyes and very smart brains, and I adore teaching you all, and I apologize for not being there. I'm sure many of you noticed that. All right, everyone. Have a great time at the BOY assembly this afternoon. I'm sorry I have to miss that. Time to wrap up. Your homework is posted on Canvas. It's just a continuation of the same study guide page as last night. Remember, the solutions I do want you to check. They are also posted to Canvas. And so, my producers, everyone, have handed me this piece of paper here, and they're telling me the following. Really? I have to read the... Okay, because it's YouTube, I am by law required to end the video by saying, be sure to like, comment, and... Is that the word subscribe? That says subscribe. Your handwriting is... Okay. Be sure to like, comment, and subscribe, and click the bell for notification. What bell? What bell do you want me to... There is no bell here. What bell do you want them to click? What are you talking about? That doesn't make any... Fine. Thank you. You know what? I can't believe I hired these people. Anyways, everyone, have a good weekend. Reach out if you need help.